Welcome to this video presentation of the laboratory activity in connecting liquid crystal display to an Arduino Uno board. In this lab activity, we will guide you to the process step by step from setting the hardware to uploading and running the code. Let's start with program number 1. So it says here, Peace, Love, and Code. We are tasked to create and design a display showing the graphics found at the cover page of this experiment handouts. So here is the display, Peace, Love, Code. So here is our simulation using the Tinkercad, and let's gather all necessary materials for this program. So we need the Arduino Uno and the LCD 16x2 I2C. So for the connections, the A4 and A5 ports is connected to the SDA and SCL of the LCD. The ground is connected to the ground of the Uno Arduino, and the VCC is connected to the port of 5 volts in Arduino Uno board. For the code part, let me explain it to you in Arduino IDE for formality. So first, we need to include the necessary library that allows the Arduino to communicate over LCD I2C, and that is the wire.h library. And liquid crystal underscore I2C.h library to provide functions to interact with the LCD. So this line creates an LCD object. So the parameters specifies the I2C address 0x27, which is the number of columns 16 and the number of rows 2 of the LCD. So this setup tells the Arduino how to interact with our specific LCD. So these are the following representation of the visual that will be presented in the LCD. So let's define first the custom characters for Peace, Love, and Code. So as you can see here, each character is an 8-byte array where each byte represents a row in the 5x8 dot matrix of the LCD. So this array represents the left part of the P symbol. This code is the P symbol, the middle part, then the right part of the P symbol. And here it only needs the left and right part of the love symbol, and code left and code right of the code symbol. So in the setup function, we will need to initialize the LCD and turn on the backlight. So this is to display the following characters and symbols in making the display visible. So these lines load the character data into the LCD's character generator RAM, and for this part, these lines set the cursor position and write the custom characters of each Peace, Love, and Code characters. So to the first line of the LCD. So in this part, this line sets the cursor position to the second line and prints the text Peace, Love, and Code. So the loop function is empty in this case because there is no need for the repeated action. So the setup function already displays the desired output. So now we will try to simulate if it is working, and we will go CAD for simulation. So let's simulate. So that's it for the simulation of program number 1. As you can see here, it displays the symbol Peace, Love, and Code, and also the text. So for the demo part, here is the video. For program number 2, Marquee message. Create and design a message marquee system. The program will be controlled by 2 light-dependent resistors, LDRs, in displaying the 2 marquee messages. And that is, if the left LDR has sense, it will display the marking message from left to right direction. Welcome to the PUP CPE department. And otherwise, it will display the marking message, goodbye, see you again next time, from left to right direction also. So here is our simulation using the Tinkercad. Let's gather all the necessary materials that is needed for this program. So first, we need the Arduino R3, the LCD. We need also a 2 photoresistor, our 2 LDRs, and 2 10K ohms resistors. For the connections, the ports out A4 A5 is connected to the SDA and SCL of the liquid crystal display and the VCC for 5 volts, and the ground to the Arduino. The 2 LDRs or photoresistor is connected to the ports out of the analog A0 and A1, and connected to the 10K ohms resistor, which is connected to the ground. And the other side of the pin of the LDR is connected to the 5 volts port of the Arduino Uno board. So for the code part, let me explain it to you in Arduino IDE for formality. So first, we need to include the necessary library that is needed for this program, and it is like the first program. We need to include the wire library for I2C communication, and also the liquid crystal I2C library to control the LCD itself. So next, this line creates an LCD object. So the parameters specify the I2C address the 0 by 27, which is the number of columns 16 and the number of rows 2 of the LCD. So this setup tells the Arduino how to interact with our specific LCD. So first, we define the constant for the left and right LDR, light dependent resistor connected to the analog pin A0 and A1. Next, we define a constant delay for each scroll step, and we define a light threshold value to determine if the light is sufficient or detected. For the setup function, we initialize the serial communication for debugging at 9600, and we initializes the LCD and to turn on the backlight. It also displays a message on the LCD initializing for 2 seconds, and it clears the LCD screen after the initialization, so it prints the LCD initialized to the serial monitor. The loop function continuously reads the values from left and right LDRs, and also it prints the values from the LDRs to the serial monitor for debugging, left and right. If both LDRs are below the light threshold, it clears the LCD screen. It also adds a small delay to avoid rapid clearing and skips the rest of the loop. So this line is, it clears the LCD screen before displaying a new message, and if the left LDR value is above the light threshold, it displays the message, "Welcome to the PUP CPE department," on the LCD. So that is our marquee, and it sets the cursor to the first row and display the welcome to the, and the second row and display the PUP CPE department. So we add a faster delay for a quicker scrolling. Next, we added the scroll, the display to the right for a total 18 characters. And if the left LDR value is not above, so since it is if-else function, if the left LDR value is not above the light threshold, it displays the "goodbye, see you again next time" on the LCD. We set the cursor to the first row and display "goodbye, see you," and set the cursor to the second row and display "again next time." So we added a faster delay for a quicker scrolling. And lastly, we scroll the display to the right for a total of 21 characters. And that's it for the code of program 2. Now we will try to simulate if it is working, so we'll go back to the Tinkercad for simulation. So let's start the simulation. Initializing. Okay. According to program number 2, if the left LDR has sense, it will display the marking message from left to right direction, "Welcome to PUP CPE department." So as you can see here, it is working. Otherwise, if the other LDR has sense, it must display "Goodbye, see you again next time," also from left to right direction. So I also want to add the LDR value in the serial monitor. So that's it for the program number 2. So thank you. For the demo part, here is the video.
Good day, I'm Joseph Pialopide, and I'm here to discuss the program number 3, a decimal calculator. In this program, we will create and design a decimal calculator that can perform the following mathematical operations such as the addition, subtraction, multiplication, and division. The mathematical expression formed from typing it by the keypad is being displayed over the LCD as well as the output of the said mathematical expression. So here's my circuit simulation using Tinkercad, and here's my code. I will further explain the contents of my code using Arduino IDE. So here in Arduino IDE, the contents of my code, I included three libraries which are the keypad.h, the wire.h, and the liquid crystal I2C.h. So I assigned the keys of the keypad to be like this: the A for addition, the B for subtraction, the C for multiplication, and the D for division. The asterisk sign is for clear, and the pound sign is for equals. Then um, the variables, which are the input string, it stores the user input, and the operand 1 and the operand 2 are the operands for arithmetic operation, and the operation tracks the current operation, whether it is addition, subtraction, division, or multiplication. So the decimal pressed and the decimal display are the flags for decimal input and result display. Then the setup function, it initializes the LCD and displays the decimal calc string, then clears after a short delay. Then it prints the enter for the input of the expression. So the loop function, it checks for keypad input continuously. Then the handle key function, it processes the numeric input, the decimal points, and the arithmetic operations, and it also displays input and results on the LCD. Then the clear all function, this resets all the variables and clears the LCD for a new input. Then the calculate function, it performs the arithmetic based on the stored operands and the operation, and it handles the division by zero errors. And this is the content of my code. So I will now demonstrate the program using Tinkercad. So I will start the simulation. Then it will print the decimal calc string. Then after a short delay, it will be cleared. Then an enter string will appear. Then using the keypad, I can input the expression that I want to calculate. So for example, I use 56 plus 6, so it will be 62. 69 minus 9 will be 60. Then if I enter 96 divided by 89 will be 1.08. And the clear function works properly. 89, 86 minus 9 here. So this is the simulation using Tinkercad, and that I will demonstrate it using Arduino.
Program 4. Password-driven Piezo buzzer. Design an Arduino circuit for a password-driven running LEDs. The program will ask the user to enter a password through the keypad. If the password is correct, it will buzz off the correct musical tone of your choice, and running LED will light from left toward right. Otherwise, it will display the incorrect running LEDs pattern of your choice, together with the sound off from the buzzer, and ask again the user to enter the correct password. Provide 3 trials for entering of the correct password. At the last attempt, if still the password is incorrect, Arduino will disable the keypad. That is, it will no longer be accepting any entering of password. It should display the corresponding prompts such as enter your name, enter your password, access denied, attempt already, welcome, name. You can set some prompt and blinking effect. So this is my code for program number 4. Now let's verify it and upload it to our Arduino. computer. So let's try it out. So first, let us enter our name. Hardware. Now let's enter our password, which is 1 2 3 4. As you can see, I have access granted. And now let's do it with wrong password. However, let's enter our name first. Then let's enter our password. 5555. Attempt 1 2 there. Now my access is disabled. So that's it for program number 4. Program number 5. DIY LCD keypad video game. Create your own LCD keypad video game. You can include tone rendition as you play the game. So this is my code for program number 5. I just created a simple math quiz game. So let's here it is. So let's verify it and upload it to our Arduino.